There we go. Recording in progress. As those of you guys who have been here before know, I always like to record so I can put it online and you guys can go back and watch it. I'll post the recording as soon as class is over. But today we'll be talking about, or I should say, we'll be continuing our kind of series of lessons on the organs, right? That's not what I wanted to do. Oh boy. Okay. For some reason, my screen just went blank. Last class we talked about the stomach, and following the stomach, it would make sense for me to talk about the small intestine, right? So that's what we're going to be talking about today. And the small intestine is, just to give you a general sense of where it is in the body, I have this diagram right here. It is right under, I have Okay, so this diagram kind of shows you that the small intestine is kind of like right under the stomach, right? And it looks like I got a chat here. Um, yes, of course, that's fine. Yes, Anthony, if you missed that class, don't worry about it. The recording, I believe, is on my YouTube, so you can stay after class and I can give you the recording link, or you can just go onto like the WeChat group chat that has all of the different like YouTube links I've sent out. But no worries there, Anthony. Today we're going to be talking about the small intestine. Okay. Let's get started. Does anyone know? Okay, well, I'm going to stand up and I'm going to show you where the small intestine is. So if you look at my body, this is my waist, okay? My small intestine is like right here. All right. My stomach is around like here. This is my small intestine. This is where all the nutrients get absorbed in my body. Okay. So now that you guys have had a visual demonstration on your teacher,
Wait. Go to the first, like the introduction page.
yep.
Isn't that like where it is?
Isn't that your what?
Where it is?
Yes. This is where it is. Like this pink thing, that's your small intestine. If you look on my body, my small intestine is like right about here.
Why is your small intestine so big?
Good question. We call it the small intestine compared to like the large intestine because it's narrower than
What?
the
What? I didn't hear you.
Okay, so it's here. Let me explain it this way. The small intestine is actually very long. Okay, and I see your hand, Eva. Give me a second. The small intestine is very long, but it's also very thin, right? The large intestine is very thick, and so that's why we call it the small intestine because it's much thinner than the large intestine. Yeah. It's very long though. Like in the body, it's pretty long. Is that okay, Daniel?
But why is it? But what? When it's technically in square inches, it's technically bigger than. I think it's probably bigger than the big. The I think it's called the big intestine.
The large intestine, yeah,
Oh yeah,
there is. I do believe there's more surface area in the small intestine. It's just because it's thinner, it's more narrow, which is why we call it the small intestine. But it kind of
oh,
makes sense. You go from small intestine to large intestine. Yeah. That okay, Daniel?
yes.
Lovely. Okay. Eva, I know you had a question too. What's up?
In school, in my science class,
Mhm.
our teacher actually taught us something interesting in science. Ironic. Uh,
Ironic.
she told me that your small intestine is about 25 feet long, which is about 3 times as long as you.
Yeah. 25 feet. So that's yeah, that is pretty long. I'm around like I'm 5'10", and so just say that I'm 6 foot. 3 times 6 is 18. So if my small intestine is 25 feet, then it is longer than 3 times my height, which should put into perspective how long it is. Can it be longer than 30 feet? That's an interesting question, Anthony. I don't really know. I suppose if you're very tall or if you're a very big person, then you might have a large small intestine.
Very big.
Yes, very big. But it's not like I know how long my small intestine is. I just know it's pretty long. But like I couldn't tell you like my small intestine is 18 feet. Like I how would I know? It's in my body. Okay. But let's get on to the actual content, okay, shall we? Oh, this picture didn't come out well. Hold on. This is not what I wanted this picture to do. But while I'm fixing that, does anyone want to tell me a little something about what they know about the small intestine? Yes, Eva.
It's like it absorbs all the nutrients from the stomach, and the nutrients just get sent in like there's like the wall of your small intestine may seem flat, but when you zoom in, it's like really bumpy. It goes through like the little bumps into your blood, and your blood absorbs the nutrients, and the waste goes into your large nutrients, and it comes out as poop.
Yeah, that is that is a really good description. And we'll talk about like the small bumps she's referring to. We'll talk about the nutrient diffusion she's referring to. So that's all coming down the line. Very good. Anthony, I believe you also had something to say.
There's like 3 parts. I found their parts. I think like one starts with D and one starts with J and one starts with I.
Yes, that's exactly correct. There are 3 parts to the small intestine, and we will talk about the structure later on in this lesson. So we will get to that. Very good, Anthony. Okay, so number one thing that Eva mentioned earlier was the main function of the small intestine is to absorb nutrients. Okay, and the small intestine absorbs these nutrients from food that has been broken down in the stomach. So remember how last week we talked about chyme, right? How chyme is what the stomach produces, right? So after the stomach does all of its mixing, all of its kind of like chemical and mechanical breakdown of your food, it turns it into chyme, right? And after that chyme has been produced in the stomach, it is released into the small intestine. Before all of that chyme, which I will spell here, from chyme, that's how you spell chyme, chyme. That is what the stomach makes out of your food. But after that chyme has been released into the small intestine, you actually get a few more things mixed into the chyme before the small intestine does its job of absorbing the nutrients, right? So number one, we see this thing called bile enter into the small intestine, right? And the bile is like we learned earlier, produced by the liver, and then stored in the gallbladder. The gallbladder is a small organ that sits right under your liver, and after the chyme has been released into the small intestine, the gallbladder says, "Oh, wow, there is chyme in the small intestine, and it's time for me to do my job," right? And so the gallbladder, it releases all of this bile into the small intestine. Now you might have a question, right? What does the bile do? Bile is the chemical, or not necessarily chemical, but it's the molecule that helps break down fat in your food, right? So if you eat something like I should say, if you drink something like milk has some milk fat in it, right? And so there's a process called emulsification of fats, and that is what bile is in charge of. It helps your small intestine break down the fat in your foods. We will also see enzymes released into the small intestine, which is really helpful in breaking down carbohydrates. Carbohydrates are the molecule that gives you energy, right? So it's really important that you break down these molecules and get them into the bloodstream, because if you don't break down your carbs, then you don't have energy in your body, and you can't run, you can't do anything. And like I mentioned, bile comes from the gallbladder, but do you know where enzymes come from? This is really interesting. You guys might not know where these enzymes come from.
The spleen.
Good guess, but no.
Stomach.
No, also not the stomach, but a good guess because it's very close.
Pink. Liver.
No. Eva?
With the small intestine?
Is it the liver or the pancreas?
These are all good guesses, but you guys will be surprised to learn that these enzymes do not come from any of the organs.
Your food?
Also a good guess, but no. This is a tricky one. So there are actually bacteria.
It's the cells. It's the it forms when like things like cells, I think, or whatever, get break down.
Bacteria poo. Bacteria poo.
It's like when like I think it's like molecules or something get broken down and part of it turn into enzymes.
Not necessarily either. So has anyone ever seen like a yogurt and it says probiotics, right? As everyone has, yes. Okay, so Eva just
Bacteria poo.
okay. Anyways, so probiotics are a word for good bacteria.
Oh,
Right?
oh, I know.
I'm just gonna mute Daniel there because he's a little excited
No,
there.
I know it's right here.
Okay, I am going to mute Daniel again until he calms down a bit. Easy there, Daniel. Okay.
Carbohydrate molecules.
Okay, I will once again have to mute Daniel. Daniel, I ask that you just calm down for a second there. Thank you.
Protein molecules turn into amino acids.
Okay, I'm really not sure what Daniel's saying there. Something about amino acids. Okay, anyways, so when you eat yogurt or when you eat like any sort of product that says healthy probiotics, you get all of these bacteria that end up living in your gut, in your small intestine, in your GI tract, in your gastrointestinal tract, right? And so all of these bacteria, they produce enzymes that are released into the chyme that then help break down the food. So that's where these enzymes come from, the bacteria that are living in your gut. We call this the microbiome, right? The microbiome refers to, hold on, microbiome. It's this word. The microbiome refers to all good bacteria or like all living organisms that are living inside of you to help you, right? Without these good bacteria in our small intestine, we would really struggle to break down carbohydrates and get energy from them. So that's where these enzymes come from. And I think I might have mentioned that here. Oh yeah, okay. And so these bacteria release enzymes that help break down carbohydrates. And there are also some bacteria that release enzymes that help break down fats. But pretty cool, right? You guys probably knew that bacteria.
Wait, what? I can't really. It kind of sounded glitchy.
Okay, so my point was enzymes are made by the good bacteria in your small intestine. We call these probiotic bacteria because they're good for you. And biotic refers to the fact that they're like related to biology and that they're alive.
I mean, like what does the second note mean?
Microbiome?
Wait, are you on the second one?
No, I'm not.
Oh, okay, sorry.
Yes. Okay.
Then what's microbiome?
Microbiome refers to all good bacteria that are living inside of you.
Oh yeah, I know this.
Yeah, okay, lovely. But this note just simply says that the small intestine absorbs the nutrients from chyme. So after the bile has been released and after these enzymes have helped break down all of the carbs and the fats and the protein in your food, then the nutrients are then absorbed. And we will talk about nutrient absorption in the structure part of this lesson. What you will also learn, which is really interesting, because when I was in high school, I was told that the large intestine extracts water from your food, and that's not necessarily true. Okay, so the small intestine extracts about.
Aren't you still in high school?
That's a good point. When I was in my no, okay, you got me there. That was an excellent point. Well done.
Wait, what did he say?
Okay, so is Johanny your name? Johanny? Johanny. Okay. So I said when I was in high school, I learned, and then Johanny said, "Aren't you still in high school?" Which is right. I am still in high school. I'm 17 years old. I'm a senior. Good point, Johanny. You got me. Okay. When I was a freshman in high school 3 years ago, okay, I was told in my biology class that the large intestine extracts all of the water from the chyme, which is not necessarily true. The large intestine only extracts about 10% of the water. The small intestine first takes out around 90% of the water, and the last 10% is left to the large intestine. And after, the large intestine like takes out the water, it's turned into like poop, and then you like excrete it out. We will talk about that next lesson. But the small intestine actually takes out around 90% of the water. And it does this through a process called osmosis. Does anyone know what osmosis is?
Is it where you make smoke?
What?
No. It is not.
I feel like I recognize the prefix os, os,
Mm.
os, whatever.
Okay, sure. So osmosis is a process where
Wait,
molecules.
I have a question.
Yes.
Do most process names, like biology process names, end with cis?
Um,
Like
no, not.
mitosis and stuff like that?
Okay. You have a point, like mitosis, meiosis, the theory of like endosymbiosis. Um, yes, I mean you have a point. There are many processes in biology that end with cis. And that just might mean like system. I never took Latin. So I'm not actually too sure what cis actually means, but I would guess that it is some kind of system, but there are also processes in biology that don't have cis, like Krebs cycle or
Digestion?
Calvin cycle or
Digestion or respiratory?
yeah, like digestion,
Respiratory.
absorption, they're like electron transport chain. There are a lot of processes that don't involve the word or the root cis. So when you see cis, it's a pretty good indication that it is some kind of system. So yes, good observation. But back to osmosis. So the way we like to explain osmosis is, does anyone know what like concentration is? Yes, Eva.
What kind? What kind?
Like concentration as like you're concentrating on like focusing on something, or like the game concentration that like little girls play.
Okay. So not the game. I'm
Maybe.
talking about like how much salt you have in water, for example.
Ah.
Like that kind of
Oh
concentration,
yeah, that's
right?
what I
So
was asking.
right. So if you have a lot of salt in a little bit of water, is your concentration of salt high or low? Let's say you have a lot of salt, a little bit of water. Yes, Eva.
Like really high.
Yes, really high. You have a lot of salt in there, right? So think about the ocean. The ocean is pretty concentrated with salt, right? I'm not recommending you do this. Don't tell your parents I told you to do this. But if you taste the ocean water, it's pretty salty, okay? Like I've spent my fair share of time on beaches. The water is salty, right? So the ocean, it's pretty concentrated full of salt, right? But if I were to take a gallon of water and add in a tiny bit of salt,
No.
right? Is that high concentration or low concentration?
Low.
Hello.
Exactly. That's low concentration, right? So if you take my water here and I drink it, that's low concentration of salt in there. There might not even be that much salt in there. But if I go and drink the ocean, it's pretty salty, right? So
You can't drink the ocean. If you drink the ocean, something will happen to your body.
yes,
Because
yes,
salt level, there's only a special kind of animal. There's only a special sea iguana that can drink that ocean.
yes. It is a terrible idea for humans to drink salt water, by the way. Like if you are super thirsty, drinking salt water will make you more thirsty. Okay. Yes, Eva.
Some well, no, he's not really a friend, but somebody at school told me that when he was a kid, he ate Play-Doh, and then
Jesus.
our art teacher said that Play-Doh is actually edible because it mainly consists of water, flour, and lots of salt. But she would recommend it, but I guess she said I guess it's okay since unless you have some sort of disorder.
Yeah,
You
just don't eat Play-Doh. Like I don't know what's in Play-Doh, but it's just not a good idea to eat Play-Doh. Like it just in general.
clay and everything. Clay is just dirt and water.
Sorry, what?
What? Isn't Play-Doh just clay?
Well, to be honest, I
It's
don't actually know what Play-Doh is made out of.
it's salt, flour, and water.
That's not what Play-Doh's made out of. I don't know what Play-Doh's made out of.
And wheat.
Oh, well, okay.
And
Well,
if you're gluten-free, then don't eat Play-Doh.
okay. Well, I can't tell you what Play-Doh is made out of. When you turn 17, you don't really know what Play-Doh is made out of anymore. Like you don't come in contact with Play-Doh often
I'm
enough
gonna
to
search it
wonder.
up right now.
Okay, yes. Search it up and put it in the chat and tell me what Play-Doh is made out of. But back to the lesson here, right? So let's focus on this diagram quickly, right? So let's look at this left side that I've just circled and let's look at this right side that we've just circled, okay? So can someone tell me in comparison which side has the higher concentration?
Right?
Yes, and Eva, what were you gonna say?
I was just gonna say what Anthony did.
Yes, right. And that's correct, right? We have the same amount of water here.
But can you move on to the second note?
We're on the third note here, by the way.
Oh, okay, yeah.
Yes.
Wait, wait. Oh, okay, yeah.
Okay.
Yeah. Sorry.
All good. No worries. And Eva and Anthony figured that out because if I erase this here, you can see that there's the same level of water on both sides, but this side has more molecules, right? So if they have the same level of water, then this one will, why does it say draw a text box? Anyways, this side will have a greater concentration, right? But now let's look at this. They have two different levels of water, but this one has more molecules, more red molecules, and this one has less red molecules. So what would you say about the concentration of this compared to the concentration of this? Are they equal? Is this one higher? Is this one lower? Yes, Eva.
Well,
No.
I mean, like the water would be this, like on the picture on the left, they're like they're like as here, but on the picture on the right, one's higher than that line, one lower than that line.
Yeah.
So I guess it's the same amount, but over here, like on this side, it's like there's a little bit less red dots, and here there's a little bit more red.
There's like 21 red dots on the right side.
You counted?
But here,
Jeez.
here,
And 7
Okay.
on the left.
So actually, if you guys count it, it might not be like what I want it to be. But just visually, you can say that the concentrations are about the same, which I think is what Eva was trying to go for, right? If you have
how is
more
it the
water,
same? Why is it the same?
I'm about to explain that, right? So if you have more water and you have more molecules, you have one specific concentration. But if you have less molecules and less water, it's about the same concentration. And you can kind of see that, right? Look at the distance between these molecules, right? You have like this distance, this distance, this distance. It's about the same here, right? Here to here to here, right? But if you look here, the distance between these molecules and these guys and these guys is different from like boom, 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 right? So the distance is about the same in this one, but they are very different here. And so we know the concentrations here are roughly equal. If you guys count them, then it might ruin my explanation. But visually they are roughly equal. Whereas this one, we can tell that they are obviously not equal, right? This is the concept of osmosis, right? Osmosis always wants to make things equal, all right? And you guys will see this a lot as you guys get on into your high school careers. You guys will see like equilibrium, Chatelier's principle, like KQ, KFC.
I was like reading a lot of science books and like literally basically a lot of things were really like a lot of the things were supposed to be like even like I was listening to a science podcast and it said that like in the air like the stuff in the air
Mhm.
it has to balance, and that's how wind happens.
Yes, you're thinking about like I believe what you're referring to is diffusion, which is very similar to osmosis, just not with water. Osmosis refers to the process of only water moving. So if you have a lot of water on one side, for example,
Wait, what are we talking about?
we are talking about how the small intestine absorbs water. Which is one of like the main functions of the small intestine to absorb water. It's like very important for the small intestine to absorb water. Yeah. Feel free to look at the slides, by the way, Colby. We haven't gotten very far. As you can see, we're still on this bullet point of the first slide, which is great. I love that you guys have a lot of questions. But we are moving along at a quite slow pace, but that's fine. I mean, I have time to teach you guys. I like teaching you guys.
Can you go up to the first slide?
Yes, this is literally just like a picture.
Could I just say what it's made of because it's way too much things for me to type.
Sure, Johanna, go ahead.
Well, it was first made of water, salt, and flour, and then 2024 they patented it to make compressed water, starch-based binder, retrogression inhibitor, salt, lubricant solvent, preservative, hardener, lubricant, fabricant, and color.
Wow, okay. So
I don't think
Eva
that's
had
cool.
Eva had some stuff right in there, but there's a lot of stuff in Play-Doh. I wouldn't recommend eating it. Okay, but anyways, back to osmosis, guys. Back to osmosis. The way your small intestine absorbs water is that there is a lot of water inside the small intestine, but there is not a lot of water on the outside of the small intestine, right? So let me see if I have a piece of paper for me to draw this for you guys a little better. Okay, perfect. Lovely. My English essay is just gone to waste, apparently. Okay, so let's say this is this is the wall of your small intestine. Okay, actually, wait, I have a draw function on my thing. What am I doing? Well, let me see if I can share my whiteboard.
What are you doing?
I'm doing my best here, Daniel. Okay. Perfect. Whiteboard. Okay, lovely. This is exactly what I wanted. Okay, so everyone can see my whiteboard now, right?
Yes.
Okay, so let's say, this is not a good color for my small intestine. But let's say everything in here is my small intestine, okay? Everything in here, right? And let's say we have a lot of water in the small intestine, right? You guys have just drank a lot of water because you guys are very thirsty, right? Your cells are nice and thirsty, right? So out here are your cells. They're thirsty. They don't have too much water in them, so they're kind of shriveled up, okay? Sorry for my bad drawing skills. But you have a lot of water out here, inside your small intestine, and you only have a little bit of water out here, right? So what do you think is going to happen? Do you think the water is going to want to move this way or this way? Yes, Eva.
Since you said osmosis wants everything to be like equal and fair,
Yeah.
the water's gonna move out, so like the cells get some water and the intestine gets some water.
Exactly. That's right. And so a lot of this water will move into the cells. This is osmosis, right? Osmosis wants everything to be equal. So a lot of this water in the small intestine, it's going to be like, oh my goodness, there's so much water in here and there is not a lot of water outside, right? So I'm going to move myself outside to make things equal. And that is exactly what osmosis does, right? Eventually you guys will get to like the point where you guys will realize that like osmosis only like balances things 50-50. And so you need like sodium, potassium pumps and active transport to move all of that excess water like out again.
I have a question.
Yes, Daniel, what's up?
Do you do like fun experiments like this?
With osmosis?
Oh yeah, like different things.
Yeah, for sure. There's a lot of cool stuff you can do with osmosis. But here, let me stop my screen share here and reshare my PowerPoint. Let me think of something quickly. Okay, I have a good example. Let's say you have a Okay, so this will employ your taste buds, but here, let me give you an example about how you could experiment with osmosis. Okay, so one thing you could do is you could take a semi-permeable membrane, which is like actually that might be a little hard for you to get, but there are semi-permeable membranes like everywhere.
I'm just asking if you like do fun experiments, like whatever you're talking about.
Like do I have a small intestine that does this that I can show you guys? Like, is that what you're asking?
No, like do you do these kind of experiments in high school?
Oh, like osmosis based experiments?
Yeah.
Depends on your teacher. I mean, you and I will not go to the same high school probably. So how would I know, you know?
What high school do you go to?
I go to Landon. It's a all boys school in Maryland.
Oh yeah, oh yeah. Oh, my teacher went there.
Oh, really?
Or my Chinese teacher.
Daniel, where do you live?
Why are you asking that?
Well, I'm asking to see if you live close to me.
Yeah, I thought we already discussed
Landon's in Bethesda, Maryland, because
Bethesda,
that's
Maryland.
what
I
that's
live
what
in Maryland. I live in
the
Rock.
website said. Me
Oh,
too. I
okay,
live in
so
Maryland. I live in Frederick, Maryland.
okay,
Near
so you
Lawrenceville.
guys are both very close to me. Okay, I live in Germantown, so
All the way.
That
Oh,
sounds
we're-
a bit.
We're like 10 minutes from
You're not
Germantown.
gonna track me down or anything, right?
don't worry, I won't. I know Colby lives in California, so
Yeah.
it's different for Colby.
Kobe lives in California.
Okay. Anyways, okay, where were we? Okay, right. Love teaching children. Anyways, now that we're done with osmosis, does everyone understand like the concept of osmosis? Like osmosis wants to balance things out, so it will move the water from the inside to the outside. Okay, great. I'm getting thumbs ups. Lovely.
Is organs inside of the water, or
Sorry, could you repeat that, Colby?
where does the organs come from?
Where do the organs come from?
Yeah, like I mean the intestines.
Where what organ comes before the small intestine? What organ comes after the small intestine?
Oh, doesn't the
Right.
liver come after the small intestine?
No. The large intestine comes after the small intestine. Colby, could you re-ask your question for a second there?
I don't really get like what it is. So,
Okay. So the small intestine sits right here, and it comes right after your stomach. Okay. And I don't know if you were here for that class, but the stomach basically churns up all the food and turns it into chyme. And after that chyme is released into the small intestine has the job of absorbing all of the nutrients from the mixed up food. So it is do you know what like a small intestine actually looks like?
no.
Okay, so
Go
let
to
me,
the first page.
okay, but that's like an artistic representation. I want to actually show Colby like what it will actually look like. So here.
Oh no. Oh, it's Discord.
So here, look. This is what a small intestine will actually look like.
Oh,
Right?
oh,
This is your stomach.
oh.
All right. The thing, you guys can see my cursor, right?
Yes.
That
Right.
looks like a kidney shape, but okay.
Thank you. Right. Kind of looks like your kidneys, right? Your stomach is, everyone thinks your stomach is really big, but your stomach is not actually that big. But this is your stomach, and this is your small intestine. So this is what your small intestine looks like, Colby. It comes after the stomach, and then it leads to the large intestine, which we will talk about later. But hopefully this helps you with like a general idea of what it would look like. Is that helpful, Colby?
Yeah.
Okay, great. And we will talk about it for further on in this lesson. But like we all know that the food can't just like sit in the small intestine. That's bad, right? And so The small intestine moves the food along by this process called peristalsis. Basically, the muscles contract and it pushes the food along in your small intestine. It's involuntary. You can't really control peristalsis, right? It's not like I can be like, I'm going to hold all the food in my small intestine right now and I'm going to stop peristalsis. You can't really do that. Yeah.
But that gets me thinking, why can't you stop gas? Yeah.
Why can't you stop gas? What does that mean?
Why can you stop your I don't know how to say it.
Yes,
Like,
Like, why can you hold in your farts?
yeah.
Okay.
Sorry I asked that though.
No, it's
I-
fine. I mean, I'm at the age where like I'm mature enough to like answer questions like normally without like laughing. But
Kids in my school will probably be laughing right now.
yes, that's true.
Yeah,
If I was
mine
around
too.
my
Mature.
Mine too.
okay, but you can control the muscles around your butt to actually hold like the fart in. The same way you can like prevent like your poop from sliding out, like you can hold in your poop, right?
Yeah.
Those are the same
Yeah.
muscles that you use to hold in your farts.
Eventually you will have to, right?
Yes, exactly. I mean, if you hold your poop for like a month, well then it's not good, right? Like then your muscles like go crazy. But
My dad told me about this guy. He wanted to experiment what would happen if he didn't burp, and then he like drank a bunch of Coke, and then he tried not to let the air bubbles come out of his mouth, and then later he was at the ER getting his esophagus, I think, or his stomach pumped, I think.
yeah, Jesus. Don't do
Yeah.
dumb stuff, okay, guys? Just let your body do what it needs to do, okay? If you guys need to like expel gas, just do it, okay? Just like not in public or anything. If you guys need to go poop. Like don't hold it in for excessive amounts of time.
If you hold in going to the bathroom is eventually gonna stack up inside of your body and destroy something. So
Yes, exactly. If you hold in your poop, it's gonna build up in your body. Like it's not good, and then you
Dumb.
need to take like laxatives, and then it's just a whole pain. Okay, so don't do that. Okay, anyways, it took us 40 minutes to get through one slide, by the way, guys. Like this is really slow. I don't mind, but like I know some of you guys probably have like classes after this, but okay. Anyways,
Yeah, I have questions.
Are we going to look at?
so we will actually do a gim kit. So you'll see,
what?
Eva. A gim kit. Well, a lot of the kids like the gim kit better than the book kit. So
What? How? What?
What's a gim kit?
a gim kit is basically like a book kit, but it's a little different. You'll see.
Okay.
There's
Okay.
a new update in Bookit called
Oh,
Tower,
there's a new update. Oh Lord.
called Tower Defense 2.
Okay, well I will.
Tower Defense 2
The,
now.
the update actually really isn't big. It's just they released Tower
Tower
Defense 2.
Defense
which is
2
really
is only
Okay,
so
I am
It's
going
literally
to.
going so viral in my school, bro.
Okay, I'm going to ask everyone to mute for a second so I can get through this slide before like an hour, 20 minutes have passed and we've gone through 2 slides. Okay, let's talk about the structure. I believe Anthony mentioned earlier there are 3 parts to the small intestine, right? Anthony, was that you?
Yeah.
Okay, lovely. It was you. So like Anthony mentioned, he is correct. We see that a lot of times we really like to break these organs down so we can classify them better, right? We like to structure these organs so it's a lot easier for us to keep track of them. Someone is in the waiting room. Okay. Anyways, oh, that's a cool name, Drake. Anyways, think about the heart, right? We have 4 chambers in the heart. Think about the lungs. You have your left lung, your right lung, your bronchioles. The same thing goes for the small intestine. We split it up into 3 parts, right? DJI, as Anthony said, your duodenum, your jejunum, and then your ileum. So those are the 3 parts in your small intestine. Once again, I will repeat them because I don't know, because you guys are young and you guys might not have like heard me the first time, and just so it's easier for you guys to remember, right? So your first one, the first part of your small intestine is called your duodenum, right? This connects directly to your stomach. Next, we have your jejunum, which is your middle part of your small intestine. And then lastly, we have your ileum, which which connects directly to the large intestine. And this is a pretty good visual representation that I found of your duodenum, jejunum, and ileum. So this kind of like purple part up here, that's your duodenum, your first part. You can see it says to stomach, which means this opening, your pyloric sphincter, which is what it's called, is actually the connection to your stomach. And then after your duodenum, you have your jejunum, which is the middle part. And finally, you have your ileum, which leads to your large intestine, which then wraps around like this, and goes off to excrete your poop. Okay. Anyways, each kind of section.
The duodenum is basically just a connection.
Yes, it is on one hand kind of just a connection, but it also has some jobs, right?
It
So
also breaks down the chemicals that's coming through.
yes, that's exactly right. I believe that was Colby, right?
Yeah.
Okay, I accidentally just like pressed something on one of you guys's by accident as I was trying to scroll through. So if you guys like see anything on your screen, I'm sorry. That was my accident. I'm not sure what I pressed, to be honest. Like I have no idea what I pressed. Okay, I'm sorry. I don't really know what I pressed, but hopefully that doesn't happen again. But like I said here in the first slide, one of the main functions of the small intestine is to break down food with bile and enzymes, right? And so that bile and those enzymes, they're released into the duodenum. This is the part where chemical breakdown happens, right? You have your emulsification of fats. You have your breakdown of carbohydrates by these enzymes that are released from the bacteria. So a lot of this chemical breakdown happens in the duodenum, right? And then we move on to the jejunum, which is responsible for a lot of mechanical breakdown, right? We say mechanical, but what we actually mean is it's just kind of like churning it. It's just kind of moving it around, right? Your teeth, they're really good at mechanical breakdown because they are like mechanically breaking it down. They are actually like separating it up. They're mixing it. Your tongue is good at mechanical breakdown because it's mixing the stuff around in your mouth, right? So we have chemical breakdown and we have mechanical breakdown. And finally, the ileum is responsible for the absorption of water, the uptake of water from the small intestine and into the bloodstream so that you may feel hydrated and refreshed and have the water necessary to survive. As always, like water is like essential for life. That's why when we go out to look for signs of life in the universe, we say, okay, let's find water, guys. Let's find water. Okay. Anyways, like Eva mentioned earlier, we have something that we like to call villi inside of the small intestine. How do I explain this? So the small intestine is not actually smooth. Okay, so let's look at this diagram right here. Uh-oh, that's not what I wanted. Here we go.
Wow.
This diagram, this is what the inside of your small intestine looks like. It looks kind of furry, doesn't it? It looks like there are little hairs sticking out. And each one of these little hairs is what we call
it kind of looks like those squishy balls with like the soft spiky things on it.
Yes.
Yeah, it looks like those.
Yes. That is a good way to think about it. That is what the inside of your small intestine looks like. And each of these little guys are called villi, right? There are thousands, if not millions, of villi in your small intestine. One thing about villi is that there are a lot of villi in the duodenum, and there are not that many in the ileum. So if we look back on this diagram here, there are a lot of villi up here. And there are like a medium amount of villi up here, but not too much villi down here in the ileum. And that's because a lot of the nutrients are absorbed in this region, and this region is really really only responsible for absorption of water, and you don't need that much villi for absorption of water. Whereas up here, you got a lot of nutrients, you want all those nutrients, and so you have a lot of villi to help. That should also signify to you guys that villi are responsible for absorbing nutrients, right? So what villi actually do is that they increase the surface area for nutrient absorption. Simply, there is more area in the small intestine for the nutrients to be absorbed into the bloodstream, right? If I, I'm trying to think of a good example. Okay, so going back to that spiky ball example, let's say you have a normal ball and then you have a ball that's like spiky, okay? Which ball has more surface area? Yes, Eva.
It'll
Yes.
be the spiky ball.
Exactly. Great. Right. And so if you have more spikes, then you have more surface area, which means you have more nutrient absorption, which is great. We really want more nutrient absorption. And so villi, super helpful for nutrient absorption.
I have a question. What's the intestinal villi?
I was just about to talk about that. Excellent
Uh-oh.
question. Intestinal villi is, why does it keep doing that? Okay. Anyways, intestinal villi is simply another word for villi. Okay. Yeah. People make up like fancy names. This is you can literally just take this and then say, we don't want all your fancy naming. Boom, villi. Okay. This is
It feels like you know how like instructions are so like they sound so like serious and they sound like very fancy, but then when you try to make and they have very fancy vocabulary, and then when you try to make one of those with like fancy vocabulary, it just never sounds right.
Mm.
And it never sounds fancy enough.
Yeah, sometimes a lot of the naming can scare people in biology. Like there are big names, right? Like endosymbiosis, for example, simply describes how mitochondria.
Microscopic volcanic.
Yes. Anyways, let's talk about the structure of each villi, right? So villi are covered in epithelial cells. Also, by the way, if you didn't know, villi also have like microvilli, which is like so like the villi also has microvilli to increase the surface area even more, which just goes to show you need a lot of you need a lot of surface area. But each villi is covered in epithelial cells, which are basically like kind of your skin cells. But these epithelial cells, they're very good at passing nutrients back and forth, or I shouldn't say back and forth. They're very good at passing nutrients into the villi for absorption, right? So let's say we're a nutrient and we want to follow this kind of path, right? So we're out here. That's not what I wanted. Here, lovely. We're out here. We're a nutrient. We're chilling in the small intestine, right? When we hit this villi, we pass through this epithelial cell because of a certain type of diffusion, which is related to osmosis, right? If there are a lot of nutrients out here, like a bunch of nutrients out here, and there are like one or two nutrients in here, a lot of these nutrients want to move into the villi, right? And once these nutrients move into the villi, they're taken up by these capillaries that run into these veins and up to the heart, where they are then pumped to the rest of the body. So all of this blood that is kind of nutrient poor, to be honest, is renutriented. I don't actually know if that's a word, but it is renutriented. It gets a lot of nutrients in it, and so it runs off into the body to supply the body with a lot of nutrients. Let's talk about some of the words here, right? So lacteal is this green kind of like tube that's running up the villi. The lacteal is a lymphatic vessel of the small intestine, which might sound really complicated, but its only job is to absorb fats. Yeah, that's what it does. It absorbs fats. Lymphatic vessels, it carries all of like the stuff that is in this green thing, so like all the fats that have been absorbed. Arteries and veins, they run to and from the heart. You have nerves. Everyone knows what nerves are. They help give you feeling. You also have the capillary network. This is where all of these nutrients diffuse into. They diffuse into the capillary network, into the capillary bed. And after they get into the capillary network, they move off into the veins and the arteries of the body. An epithelial cell I talked about earlier, they cover the villi. Okay. Any questions about the general structure of villi or just anything about that in general? Lovely. Okay. We're moving at a good pace here. And like I talked about, we have bacteria in the small intestine, which help break down fats and carbs, and they help maintain proper function, right? If you don't have a lot of probiotics, you will, oh, that's not what I wanted to do. If you don't have probiotics, you won't have a very healthy gut. And so you do want to, you do want to have healthy probiotics in your gut. Okay. Any
I
questions?
have a question.
Yes.
Why can't they just say microbiomes instead of like probiotics?
Okay, so this is kind of a business and biology question, right? Maybe you guys want to grow up and get into the intersection of business and biology.
No,
But,
no,
Okay.
no, not at all.
Well, okay, well, I don't know what you guys want to grow up to be. But so microbiome kind of refers to all of the positive bacteria inside of you, whereas probiotics refer to the good stuff in your gut, the good bacteria in your guts, like in your small intestine, in your large intestine, blah, blah, blah. You know?
Yeah.
Okay, lovely. And also like what sounds cooler, probiotic or microbiome?
Microbiome.
Oh, you think microbiome sounds cooler?
Probiotic.
Yeah,
Okay.
probiotics just sounds like you have to take your medicine.
Okay, personally, I think probiotic sounds cooler. So if I put the word like probiotic on my yogurt, people are gonna be like, "Oh, that's cool. I'm gonna buy this yogurt because it says probiotic." Like that's marketing 101. Whereas opposed to like where I put like microbiome on it, and they're gonna be like, microbiome doesn't sound that cool. But if I put probiotic,
How? What? No,
well,
no.
It's a
But
pro.
the thing
Yes.
is, probiotics just sounds like, to me, it basically means yogurt.
well,
You-
here's the
which I
thing,
don't really
right?
like.
You eat too much yogurt. That's all I can say.
Okay, but yes, that's true. Probiotic, if you associate probiotic with yogurt, you're having too much yogurt. But actually, well, that's not true. Yogurt is very healthy for you. But just the word pro in probiotic means that like pro means good, like professional, like pro
Whoa.
like prodigy, for example. These are all like good words. Like prodigy means like you're a child genius. Professional means you're good at what you do, like you are a professional. And probiotic means good biotic, right? Like good bacteria. So the word like pro kind of signifies in like the adult mind, when they go to buy like yogurt, they're like, oh wow, it's pro, so it's good, right?
I
But
love
microbiome,
yogurt.
it's not like it's pro microbiome. It's just microbiome, whereas it's like probiotic.
Microbiome is like a small place, a small desert or something. That's what it sounds.
Microbiome just sounds cool. I'm gonna start a debate on this at school.
Okay, you have fun doing that, Daniel.
Or do you want to
I'm gonna make a war.
Okay, you do that. You start that debate at your school, and you get back to me about what your classmates say. Okay. Anyways, let's talk about diseases. You guys know I always like to wrap up these organ lessons with a kind of
because diseases are important to know.
Yes, diseases are important, and it's good to know a little bit about public health, and how these organs that you guys just learned about, how they can go awry, because not everything is perfect in the human body, right? So first of all, as with every single organ that I've talked about so far. The heart, the liver, the lung, the heart, the liver, the lung, the stomach. These organs can all get cancer, right? Which makes sense, right? Cancer is just mutated cells. And so these cells can mutate anywhere in the body. They can mutate in the throat, for example. You can have throat cancer. They can mutate in the lungs. You can have lung cancer. They can mutate in the small intestine. You can get small intestinal cancer, which is rare compared to a lot of other cancers. It is very rare, in fact. But you guys also know that I like to talk about how these things can happen, right? And so a high fat diet can lead to cancer of small intestine. And what I really don't like to tell you guys is that researchers don't really know why, right? We know that there's a link between high fat and risk of intestinal cancer, but we don't really know why high fat leads to intestinal cancer. It might be because if you have high fat, you need a lot of bacteria in your gut to digest and break down all this fat, and that can lead to problems, right? We like to think of these bacteria as like super good for us, but everything needs to be in moderation, right? We need to control everything in our bodies. And so that is one possible risk of small intestine. There's also Crohn's disease and other GI tract diseases, and I'll talk about Crohn's disease next.
Can I tell you what you kind of sound like?
Yeah, sure. What do I sound like?
You sound like the president trying to manage the body.
Well, I mean, I kind of am, right? I'm trying to do my best to teach you guys, and you know, I'm sure this job is just as hard as being the president.
Yeah. Really hard.
Yeah, totally. Running the nation is hard. Anyways, Crohn's disease is one possible reason of small intestine cancer. And again, we don't really know what causes Crohn's disease. Like, why are some individuals more susceptible and why are some individuals not, right? We know that possibly family history can lead to Crohn's disease, that it is passed down in families. We also know that smoking can lead to all sorts of different cancers, not just like Crohn's disease issues. Like smoking gives you like lung cancer, like messes with your throat. It's just bad for you in general. But smoking can also lead to something like Crohn's. Again, we see a high fat diet, which is why we're advised to stay away from high fat, along with like just the general issues with high fat being like bad for your heart and like bad for your body in general.
Do only contagious viruses or diseases affect generic like disease stuff?
Wait, I'm sorry. I didn't understand the question.
Like you said that it could pass on from the family generations, right?
Yes.
So is it only affected if it's contagious or can it be anything?
Okay. So when I say it's passed down from families, I mean it's in the genes, right?
Yeah.
Like it is passed down through the genes, not passed down through like contagiousness, for example.
Wait, so it has to be affected in the DNA, right?
Yes. We know that it is possibly Crohn's disease has some connection to messing with the human genome, right? But it is hard to figure out where like what is messed up and like it's also hard to identify a gene that gets messed up because they're like it could be more than one gene, it could be hundreds of genes, it could be we don't know, right? We don't.
Wait, so the more genes.
Oh, sorry. I completely just muted Colby by accident because my sorry, Colby.
So the more genes are affected, the more worse it is, right?
Not necessarily. The more genes that are affected, the harder it is to track like among family members, but not necessarily like the worse it is. it's just like Crohn's disease will always be bad, right? And it will always affect like generally the same number of genes. It's just if there are a lot of genes that are affected, then it's just difficult for us to track Crohn's disease through families. Yeah.
Okay.
Yes. Think about like the same way heart disease, like being susceptible to heart disease can like heart disease can be passed down through families. Same way like Parkinson's can be passed down through families. Or like hemophilia can be passed down through families. And so it is just like that. But basically Crohn's disease is inflammation in the digestive tract. It could be because of like I mentioned earlier, like smoking, high fat, but it could also be an autoimmune disease where the body's immune system attacks itself and mistakes something in the small intestine for a foreign kind of like a foreign substance, and it goes into attack mode. It attacks the body's own small intestine, and that leads to inflammation and eventually Crohn's disease. Okay, any questions, anybody?
Nope.
Okay, lovely. I'm going to stop my screen share. Oh, wow, we have a lot of people. Okay, maybe this is a good time. But I'm going to stop my recording here.